All right, so I know that the lengths are kind of weird, but I kind of had to do that because I kept finding 45-degree angles in my calculations. So yeah, they're weird. Anyways, we got to find out if this truss is statically determinate, and we do that by using this formula: 2j equals n plus r. Two times joints equals members plus reaction forces. I have a pin joint which has two reaction forces and a roller joint which only has one. We can see that 10 equals 10, so this truss is statically determinate. Alright, so now we're going to find angle A. How do we find angle A? We are going to use the inverse of tangent, and through SOHCAHTOA, we know that tangent is opposite over adjacent. All right, so looking at these angles, we can see that our opposite is 2 feet and our adjacent is going to be 4 feet. Plugging this into a calculator, we see that our answer is 26.57, and that is going to be our angle for A. Now, if we do the same process, we can find angle B, which would be 63.43. All right, and we know that in triangles, they add up to 180 degrees. And if we add up angles A and B, we get 90, and we know that 180 minus 90 equals 90, so that means that angle C has to be equal to 90. All right, here's a little free body diagram of the angles on this side of the truss. All right, now we're going to do our external uh, moments, and we know that some of that has to be zero. So if we write down, the moment of angle A has to be zero, moment of angle C has to be zero, and D have to be zero. All right, and I forgot to write them down, but at angle D we have our pin joint. At angle E we had our roller joint. I'm getting used to this. I'm doing this on an iPad, and I've never done this on an iPad, so like I don't know. I'm new to it. But anyways, so we have 200 going down, and that's 8 feet from the pin joint. So that's gonna equal 1600, and it's gonna be positive because you know draw that arrow. It's going to be counterclockwise, which makes it positive. Same thing with moment of C. Um, but with moment of D, it's not really there, so it's gonna be negative. All right, since this has to be added up to zero, we know that 1600 and 600 is equal to 2200, and we divide that by 2 in order to make this equal to 0, but it has to be a negative because it's clockwise. All right, so now we are going to calculate the reaction forces. Um, and here I am drawing out my pinned and roller thingy, whatever, and the roller has 1, while the pinned has 2. By the previous calculation, we can determine that the roller reaction force is going to be a negative, meaning we can draw that arrow. Alright, so to find the reaction forces on the x-axis, it's going to be pretty easy because we only have 2, one on E and one on D. And I think I wrote this wrong. We know that our D is negative 1100, so we know that top is gonna have to be 1100. All right, now we're gonna be doing the same thing, but in the y-axis. All right, now we're going to solve for the forces at the joints, and this guy solving a truss use this like little technique thing that I'm doing now, and I kind of liked it because it like helped me view it better. Anyways, we have to figure out the forces on the x direction and the y direction, which will be pretty easy for the x direction because we only have 2 of those, and we know that it's going left 1100, which means BD is gonna have to be going right which is positive 1100, and DE is also simple because it's it's the only one there. Alright, now here we're splitting line BE into a triangle, and then we'll have a BEX and a BEY, and we'll do the same thing solving for our X's and our Y's. All right, here I'm just going to fill in some information that we figured out. Now we're going to solve C, and again we follow the same process. Now that we know our AC and our CB, finding out AB will be really easy. All we have to do is Pythagorean theorem, a squared plus b squared equals c squared. Now, as a final answer, I'm going to draw a free body diagram of all the information that I've figured out.